Hello students, welcome back to AriserTalent. I am your maths teacher Arpita Sharma. Student, we are discussing this chapter circles. Okay, so we were talking about circles, and in circles this chapter specifically we have covered the definition part, the basic questions, the basic definition, and then the basic theorems of it, about the code, what are the angles, angles obtained at the center or at the another point on the circle. We have gone through it and we have proved some theorems and converse of it. So in my previous class we were talking about this theorem and we have proved that there is one and only one circle passing through three given known collinear points. So we have proved that particular theorem. Now what? Draw, this is your exercise question. So this is draw different pairs of circles. What you have to draw? Pairs of circle. That means two circles you have to draw. What? Two circles you have to draw. How many points does each pair have in common? Now you can draw infinite pairs of circles, but what you have to do? You have to have that thing in consideration that it's asking about points does that pair have in common. How many? Okay, then what is the maximum number of common points? So we will take it one by one. One by one, how? Let's see. It's saying that drawing a circle, two circle, basically pair. Okay, so different pairs of circles. So if I am drawing the circle here, let's suppose this is my first circle. Not a circle at all. Okay, let's reconstruct it. So let's suppose this is one circle. Now if I have to create a pair, I have to draw another circle. Now what are the different ways of that? First, if they are not touching this. Okay, so this is the first method. In the second case, they will just touch at one point, and this is the second case. Now if I talk about the third one, this is C1, this is C2, this is C1 and this is C2. Pair, so pair first, pair 2, this may be the condition. The third one, if this comes slightly between here, so what will be the result? That will be like this. This is C1 and this is C2, right? So these are the three cases. Okay, now look at it, look at the board. Now you can just answer by seeing these three diagrams. You can definitely tell me the answer of the second question, which is exactly depending on that particular answer. How many points does each pair have in common? How many points does each pair have in common? Now look at the first one, the C1 circle, the C2 circle. In these two circles, students, you are having no any point as your common point. Okay, that means you are having here zero number of common points. Zero number of common points. Okay, I am repeating, zero number of common points in the first case you are having. In the second case, you will be having only one point of contact. So you will be writing 1. In the third one, see it, here it's 1, here it's 2. So these are 2 points. We can mark it also. It's P1 and P2. That's point of contact basically. That will be 2 points. So can I write the answer of the second one as 0, 1 and 2. Right. Now the third one, what is the maximum number of common points? What will be the maximum number of common points when two circles are having common points in them? So student, if this is the condition, we can just have that some more example. If this is one circle and the another circle intersecting it at any point, maybe it will touch, there will be only one point. If it's intersecting it like completely, that can be the reason, that can be the situation, that can be the situation, that can be the situation. Okay, in these all situation, whenever I am talking about two circles, right, whenever I am talking about two circles, so if I am talking about this purple one, okay, and this green one, let's suppose this is green. So there are clearly how many points? See, purple and the green one, 1 point and 2 point, 2 point contacting. Okay, in this case, let's suppose we are having it with the white color chalk. Okay, so if I'll be asking you to pick any two circles, like this is C1, this is C2, and this is C3. Okay, and C4 is here. This is C4. If you pick any two circles, you will be finding only maximum of 2 points can be drawn. In this second case, in this case, if the situation is like this, there will be 1 point. In one more case, there may be one more case. What? That will be the one circle. That will be the C1. Okay, so this is C1 and this will be the C2. In that case also we are having only one point of contact. So that is 0, 1 or 2. That's final. No any other condition can be here obtained. Okay, now if I talk about this, what is the maximum number of common points? So simply we have what are these? These are the number of common points in all the situations we can have. Okay, when we are having two pair, when we are having a pair of circle, or when we are having two circles. So that means either we are having 0 point of contact or 1 point of contact, or common points, or 2 common points. That means maximum of 2 common points. So how many maximum number of common points? 2. Okay, and how many points will each have? This is 1, 2 and 0. Is this clear to you? Okay. Noted. Then we'll move forward to the next question we are having. Noted? Okay, now the next question we are having is, suppose you are given a circle. What you have given? A circle. So just first draw the circle you have given, you have provided with. So this is your circle. Okay, and this is the center of the circle. Now it's saying that give a construction to find its center. So basically the center is not given to you guys. Okay, so the center is not given. Center is not given and you have asked about, or you have to locate the center. Now if you go back to the lecture, I guess 1 or 2 lecture before this lecture, you will be finding I'll be telling you about the construction of circle by 3 given points. Here we are not having any 3 points, but I told you that if you are not provided with 3 points, you can take any 3 points. Take any 3 points on the circumference or perimeter of the circle. So here are my 3 points. These are, this is P1 and this is P2 and maybe this is the P3. Now what you have to do? What you have to do is just meet P2 to P3 and P2 to P1. So what you are getting, basically P1, P2 is a chord and P2, P3 is a chord. Now if you have the perpendicular bisector of this and you will be having perpendicular bisector of these, that means perpendicular bisector of these two chords will be intersecting on the center of cause. Okay, so if I'll be having the perpendicular bisector of it, okay, I'll mark like this, here like this, and will have this line as perpendicular bisector of P2, P3. Now if I talk about P1, P2, okay, so what will I do? Again, the perpendicular bisector will be there. I'll be meeting them, and this point that which is the intersection of the perpendicular bisector of P2, P3 and P1, P2 will be the center of cause. So that is the way how will you get the center of the circle. Okay, note it. Okay, so if we do this with the help of our compass, then how will we do that? Okay, be having a circle here. Okay, so let's have the circle here. So let's suppose this is the given circle. This is the given circle. Now you don't know the center. Okay, you don't know the center. Now what will you do? You will be taking 3 points. 3 points, that is P1, P2 and P3. What I have told you. Okay. Now I will be having your scale with you. Any random 3 points I am telling, you can take this P3 here also, you can have this P1 here, P2 here and P3 here also. The distance between the points, the location of the point doesn't matter, you are having only, you have to have only 3 points and you have to have 2 chords out of them, and that's so easy. You can even have P1, P3 as one chord and P3, P2 as one chord. Or you can have P1, P2 as one chord and P2, P3 as one chord. And if you are having P1, P3 as one chord and P3, P2 as second chord and P2, P1 as third chord, then it's also okay. If you draw the perpendicular bisectors of these 3 chords, that will be intersecting on a single point, okay, the center, right. So what will you do now? You will be meeting this P3 to P2, right, and this okay. So you will be meeting this P1, P2 and P2, P3. Now you will be doing the perpendicular bisector. Whenever you are constructing perpendicular bisector of any line, what you have to do? You have to open this in equal to more than the half and less than the complete length. Okay, so more than the half is something like that. Okay, so we'll cut a mark here and a mark here, right? And from this point P2, we'll be having a mark here and having the another mark here. So these are the 2 points, right? Now about this line P1, P2, okay, you are having a mark here and a mark right there. Similarly from point 2, we will cut an arc here and an arc here, right. Now what you have to do, simply you have to join the lines. These are the 2 points for the P2, P3 lines, so just meet them. Okay, so this is the one line and the second one is here. So this is the one line and this is the second line. So the intersection point of these two, the intersection point of these 2 line is what? This will be your center O. And when you will take this center O as center, okay, and be finding that if you are having this point here or if you are marking it here, or if you are marking it here at this point, so you will be finding that will be the same distance from each and every point. That means this is the same circle. If we draw from this point, that means the circle is same, that means this is the actual center. Okay, so this is how will you draw it. Not, or you can just copy the steps. I have make you guys written the steps of this construction. Okay, so about the next one, let's see what's here. If two circles intersect at 2 points, prove that their centers lie on the perpendicular bisector of the common chord. So we are talking about two circles here, and two circles. First is we are talking about two circles. Then they intersect. So two circles are intersecting at 2 points. So this is the condition. Okay, prove that their centers lie on the perpendicular bisector of the common chord. Okay, let's take two circles. Let's take, this is the center of one circle, and this is the second circle of this is the center of the second circle. Okay, with any radius I am drawing these circles. Okay, so this is the circle number 1, and for the circle number 2 I am just adjusting the radius, because it is nowhere given that the radius has to be the same, the radii can differ. So I am having two different circles, but these circles are basically intersecting each other. Okay, so this is the circle C1 and this is the circle C2. This is the 2 points. So the common chord of this circle and this circle, what will it be? These 2 points, you will be meeting them. So let us suppose this is the point P1 and this is the point P2, and this circle's center and this circle's center. So this center is O and this center is O dash. Okay, now if I am meeting these two centers, right, and if I will meet these two lines, what it is saying, prove that their centers lie on the perpendicular bisector of common chord. If I will meet these two centers, just I will meet these two centers, by construction even you can see that this is looking like perpendicular to that one and you can measure it also, but we have to prove that actually in each and every case this chord, this common chord will be the perpendicular, sorry, these two lines, this line which is made by the meeting these two centers of the circle will be the perpendicular bisector of this common chord. Okay, this we have to prove. Now for construction what we will do, we will meet this point P2 to O and P1 to O, and then P1 to O dash, and O dash to P2. Okay, so this is our construction. Construction is here in the blue colored chalk. Okay, this particular section is construction. So what we'll do, first of all we'll write the thing what we have to prove. So we have to prove, what we have to prove, that this is the perpendicular bisector of O dash is perpendicular bisector of P1 P2. such that, or you can just directly write it, O dash is perpendicular bisector of P1 P2. Okay, this you have to prove. To prove this, you have to prove that this point we can name it M. Okay, this point is M. So to prove this, you need to prove two things, that P1M is equals to P2M. That is, this line is bisecting this line and this line is perpendicular to this line. And second, you have to prove that angle P1MO equals to angle OMP2 equals to angle O dash MP2 equals to angle P1M O dash is equals to 90 degree. That these four angles, these four angles are 90 degree. One, this you have to prove. Second, this section P1M is equals to MP2. This you have to prove. Now, what was our construction? Our construction step was meet P1 to O and, or you can write it in this way, that meet O to P1, O to P1 and P2 and O dash to P1 and P2. This is your construction. Okay, note it. After constructing it, you will be having here a proof. So, what about the proof? What is about the proof? So, you have done with this. Okay, because I am rubbing this one. Okay, I am shifting this particular these particular line here, and we will be doing this solution in two parts here. Okay, so note it. Right. The second one is angle. I am just copying this. Okay, need not to worry. O dash M P2 equals to angle P1M O dash equals to 90 degree. This you have to prove, and we are talking about the proof here. So, we will talk about the proof in two sections of our board, that is here and here. Okay, right. Now, the proof. I will be taking two triangles, right. Which and which triangle? First, I will take P1 O dash and O dash P2. Okay, in triangle O P1 O dash and O P2 O dash. Look carefully which triangles I am taking. In the first, I am taking this triangle. This is the one triangle I am taking. Okay, and the second one is this. These two triangles I am taking. I am taking these two triangles and I am going to prove them congruent. Okay, this is the basic strategy, and after that I will be taking this triangle and this triangle. I am again going to prove them congruent, and based on their facts, that if they are congruent, that will follow, based on that followings, I will prove the above mentioned thing. Okay, right. So, in these two triangles, this O dash is common. O dash equals to O dash. Why? Because they are common sides. Right. Now, O dash is common. Then Look here, this OP2 is equals to OP1. OP1 is equals to OP2. Why? Because they are radius of the circle. Okay. So, this OP1 equals to OP2. Right. Similarly, P1O dash equals to P2O dash. Why? Because they are radius of same circle. So, by SSS congruency, this triangle, which triangle? O dash P1 is equals to O dash P2. Right. What is the conclusion I am having from here? I am taking this conclusion, if these two triangles are congruent, then angle O, that means O dash OP1. Okay, this implies that angle O dash OP1. For angle O dash OP1, what will it be equals to? This angle O dash OP2. Right? That means this triangle will be equals to this triangle. Not triangle, angle. This angle will be equals to this angle. These two angles will be equal. If these two angles are equal, if this angle is equal, can I write P1O dash? Can I write angle P1O dash equals to P1OM? Okay. So, that will be triangle O dash O. That will be triangle MOP1 equals to triangle MOP2. Look here, it is the same triangle MOP1 and MOP2, right? These two triangles are same, and this is my conclusion number 1. Right? Now I am going to take the another triangles. I am now going to take this triangle. Look, which triangle is it? OP1M, and I am taking the second triangle. And this triangle is OMP2. I am taking these two triangles and I am then going to prove them equal, congruent. Okay, so in triangle, what you say, P1OM and triangle P2OM. We have proved, we have this thing here, P1OM equals to P2OM, right? So, we can have that this angle is equals to this angle. So, angle P1OM equals to angle P2OM. Angle P1OM equals to angle P2OM. Okay, this is for sure. Now, this OM is common side. So, OM equals to OM. Okay, so this OM equals to OM. This side is equals to this side. OP1 equals to OP2. Why? Because they are the radius. OP1 equals to OP2 because radius of the same circle. Radius of the same circle, students. Okay. That means we are having angles side and side. So, by SAS congruency, this triangle P1OM is equals to triangle P2OM. If that's so, that means what does that say? If these two are congruent. Okay, correct the sign of congruency here. Okay, I haven't put this mark on it. So if these two triangles are congruent, that does mean that this P1M is equals to this P1M. Now this P1M will be equals to P2M. Now we have to prove that P1M equals to P2M. Proved first part. So I am marking it because this is important to me. I have to prove that only. Now again, talking about angle P1MO, angle P1MO, angle P1MO, angle P1MO will be equals to angle P2MO, P2MO. Now look at here, P1MO is this angle and this angle is equals to P2MO, which is this angle. That means these two angles are equal. From this congruency, these two angles are equal, these two angles are equal. That means, what does that mean? That means that this is a line, this P1, P2 is a line. If this angle and this angle is equal, that means the summation of these two angles is equals to 180 degree. If two angle equals to 180 degree and both angles are equal, that means one angle equals to 90 degree. Okay, right. So here you can write that but P1, P2 is straight line. P1, P2 is straight line, implies that triangle P1MO plus triangle, not triangle, this is angle P1MO plus angle P2MO equals to 180 degree, because it's a line and two angles are forming a line that will be 180 degree for the straight line. Okay, that implies that angle P1, or you can write 2 angle P1MO, 2 angle P1MO equals to 2 angle P2MO equals to 180 degree. That means angle P1MO equals to angle P2MO equals to 90 degree. Now this is what's worth writing the second part. Not the second but the third. Okay, so this is the third equation you are having. Right. Okay. Now come this side. Now look here, this is a line and this is a line. Again I am telling you with another colored chalk. Look, this complete is a straight line and this complete is a straight line. If you are having two lines cross to each other, then these opposite angles are what? Equal. Okay. So you can see that side P1, P2, or should I write it here? Okay, write it here. Okay. So after that you are having it here that angle O dash P2, O dash M P2, this particular angle is equals to angle P1 MO and angle P1 MO equals to 90 degree. Okay. Now again this triangle OMP2 equals to this triangle, this angle P1 MO dash. So angle P1 MO dash, that is equals to 90 degree again. Okay. So by this fourth, so I can write by fourth and by second, by equation second and fourth. Hence proved. These four angles are now equals to 90 degree and this side P1M equals to P2M. This we have to calculate. Okay. Note it. Note it completely. So students, in this particular session we get to know about some theorem, okay, and we have proved that if we are having 2 points, these 2 points are intersection points that came from the intersection of 2 circles, okay, and after the intersection when we meet these 2 points and created the common chord, okay, and we meet the 2 centers of the circle, where we are taking 2 circles, so 2 centers. So the line joining the center of the circles and the common chord are perpendicular to each other, and it also bisect. Okay. So note it and do some questions on that with the AriserTalent sheet, of course, and we'll meet in our next lecture. Take care, students. Bye bye.